Hi guys, today I'm going to be working through some examples from 2.3 from your jacplus textbook, and there are three here to do, a cos one, a sine one and a tan one. So look, let's get started. So here we have our equation, root 2 cos x plus 1 equals 0, and the first thing we need to do is to just rearrange this so that we get the cos x by itself. So I'm going to minus 1 on both sides, which will give me root 2 cos x equals neg 1, and I'm going to divide by root 2 on both sides. So I get cos x equals neg 1 on root 2. So now I have something that I can work with really easily. And what you can see is that negative 1 on root 2 is not in the table of exact values. It's not anywhere, let alone in the cos column there. So what we want to do is draw the basic angle. So the second thing I would do would be to draw a unit circle and to put a diagram representing the cos x equals 1 on root 2. So the 1 on root 2 would be here because cos is the base length of your right angled triangle, and our x value, if we have a positive 1 on root 2, we look in our cos column and we go across and we can see that it's pi on 4. So that means that here is pi on 4. So in this quadrant 1, your cos value would be positive, but we're actually looking for negative. So what I'm going to do now that we understand, where the basic angle is, let's put that triangle into the quadrants where cos is going to be negative. And we know that cos is going to be negative here because your x value would be negative, your y value would be positive, but that's not really relevant for us because that would be talking about sine. Sine corresponds to y, cos corresponds to x. Here as well, if you had a point here, your x value would be negative. Your sine value would also be negative, but again, we are just referring to x values or considering x values because that represents cos. Cos is this length here. So this means that we're going to have negative 1 on root 2 because our cos value is negative. So we've taken this triangle from here and moved it around, so now it exists in quadrant 2 and quadrant 3, and our angle here is still pi on 4, and of course here pi on 4. So now we just need to describe the angles as they apply from 0. Now a bit of a handy hint is that if you are dealing in radians, which we are, we can see from the domain there, 0 to 2 pi, that we're going to be dealing in radians. Well, you should label your angles here from 0, and then over here is pi, but it would be more useful to call that 4 pi on 4. So we call it 4 pi on 4, it has the same denominator as pi on 4. And then, well, if we were to go around the circle more, this would be 8 pi on 4 over here. We're not going to need that this time, but just, for future reference. Now notice also that the angles we have drawn make up the wings of the butterfly. So if we were going to draw a butterfly, it would look like this. So your triangles, when you draw them, they will be always part of the butterfly in these sort of examples. Now, let's measure from 0, and we've got to go up to this stick here. So we always measure from 0. And if we were going to go all the way here, that would be 4 pi on 4. And then back a bit. So we go positive 4 pi on 4 and then minus pi on 4 to get to that place there. So our first value for x would be 4 pi on 4 minus pi on 4. And of course that's going to equal 3 pi on 4. So let's check that that's part of the domain. 0 to 2 pi, yes, 3 pi on 4 does fit into that domain. So that's one of our solutions for x. Let's look at the next one. So remembering that we can go 0 to 2 pi. So now I'm going to go from 0 around to the next stick, which is here. And we can see that we go past 4 pi on 4 and then we add on another pi on 4. So x is going to equal 4 pi on 4 plus pi on 4, and that equals 5 pi on 4. So our second value for x is 5 pi on 4. Do we have another angle? Let's have a look. So I could go around the circle forever. The circle never ends. So I would go, I've already done that one, I've already done that one. Let's keep going round, 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 all the way up to here. So this would be 4 pi on 4, 8 pi on 4, 12 pi on 4 minus pi on 4. It gives me 11 pi on 4. And well, we can see that that is too big. 11 pi on 4 is bigger than 2 pi. So actually our only solutions are 3 pi on 4 and 5 pi on 4 for this one here. Let's move to the next one. And this one's a bit different because, well, first of all, we're doing sine, not cos. But secondly, we've got degrees. And we can see clearly that it's going to be degrees. There's no pi in it, and also it's got the degree sign. So let's see, I've put the table of exact values here, but it looks like we will not need the table of exact values for this one. This looks like it might be a CAS one. So let's see, 2 sine x equals negative 3 on 2. And I'd definitely be dealing with fractions where possible, not decimals. I'm going to divide by 2 on both sides, giving me sine x equals neg 3 on 4. Okay, so, or negative 0.75 if you like. So what we can see here is that this is not a value in the table of exact values. So if we look in the sine column, there's no 3/4 there. So this means we're going to be having to use CAS. So let's draw a picture of what this represents. So I'm going to do it in the first quadrant for a start. So I'm going to deal with the positive. And the sine value of a triangle in the unit circle is that height of the triangle. And this is x, the angle, and this height of the triangle is 3/4. So we want to find out what that angle x is. So we're going to use CAS, and it's going to be the sine inverse of 3/4. So we're doing the positive, and we want to find it in quadrant 1. And that is, I shall just do that, 48.59. So that means that this angle x is 48.59. I'm not going to, I might put an arrow across. I don't think it's going to fit in there. So now I need to decide where it's going to be to make that negative. So see, we've got a negative 3/4 for our length of sine. So we know that sine is positive here because the y value is positive. In this quadrant, the x is negative, the y is still positive, so we don't want that, we don't want that. In this quadrant here, x is negative and sine is negative, so your x and y values are negative. So yes, we want the negative sign. And lastly, in this quadrant, if we had a point, the x value would be positive and the y value would be negative. So yes, we want to include this quadrant too. So I'm going to draw the unit circle again and draw the triangles that we are going to deal with. So here, and we've got one there, and we've got one here. And we have found that the x value is 48.59. So 48.59 exists here, and 48.59 exists here. And think about it that we're just lifting this original triangle up and flipping it around and putting it in these other quadrants. So we see that the y values here, the lengths here are still the same, they're 3/4, but because they are in the negative zone of the y-axis or the sine axis, they're going to be negative 3 on 4. So these are our triangles that we need to refer to when we're solving for x. Let's see. So we're looking at degrees now. So here's 0. Here's 90, but that's not going to be very helpful for us. So if you use 0, 180, and then if we go to here, it's going to be 360. If we go around again, it's going to be 540. If we go around again, it's going to be 720. So let's see what angles we've got from 0 over to 180 and adding on 48.59. So x can equal 180 plus 48.59. So that's our first angle. What does that equal? X equals 228.59 degrees. So that works. I'm going to highlight that. And it's good to highlight your answers when you know that they are correct, because sometimes you'll do one that's too big or too small, and you want to make sure that that's not included in your answer. So you want to make sure, and by highlighting it, it forces you to check that it fits in the domain, remembering that our domain is from 0 up till 720. So we need to make sure our angles fit into there. So look, let's go the next one. So I'm going to go from 0 to 180, and I want to get to here. So this would be up to 360 in the positive direction, then in the negative direction by 48.59. So I've done x equals positive 360, and then in the negative direction by 48.59, remembering that the negative direction of the unit circle is this way and the positive direction is this way. So x equals 360 minus 48.59 equals 311.41 degrees. So does it lie within our domain? Yes, it does. It's not smaller than 0. It's not bigger than 720. So I'm going to highlight that one so that I don't forget that that's one of the answers, and it's very clear when I'm getting the marks that I've found that angle. Now, 311.41 is not very close to 720, so I suspect that we have another one, and in fact I know we have another one. So what we're going to do, we're going to keep going around the circle. We've done this one, we've done this one, so then we just go around again until we get to here. And in this case, we've gone, let's count around, 180, 360, 540, plus 48.59. So this x equals 540 plus 48.59. And this looks like it will also be within the domain. X equals 540 plus 48.59 is 588.59. It's an easy one. So that is also within the domain. We're getting closer to 720, but we still haven't exceeded it, so we still will try another angle. So let's go around again. I might just choose a different colour. Okay, so if we start at 0, 180, 360, 540, I'm going to go all the way to 720, so plus 720 minus 48.59. So x equals 720, or positive 720, and then I go in the negative direction by 48.59. 720 minus 48.59, x equals 671.41 degrees. So that also is within the domain. So I'm going to highlight that as well. And look, now I'm at the stage where there's no more. And I can see that because, well, if I go 180, 360, 540, 720, to go one more and a little more is well over 720. So that's enough. I've got all the angles that I need to consider there. All right, last one. So this is a tan one, and look, this one I can see includes some negative values for our in our domain, and also it's going to be the tan value that we come across very often. So I'm going to add 1 on both sides, which gives me tan theta equals 1. And even without the table of exact values, you should know that the tan of 45 degrees or pi on 4 will give us 1. We're still going to draw it and we're still going to look at it in the same way, but this is something that comes up quite a lot, not just in circular functions. Notice that I put the table of exact values for these questions just to make it easy and just so you can see how we go about reading the table of exact values, but you do need to memorize that. So you can derive the table of exact values, I've done a video on that, or you can memorize it in some other way. Let's do tan theta equals 1. So I'm going to draw a picture, and well, this is positive anyway, so tan theta equals 1, and we've already said that, well, it's pi on 4. There's the 1, and that in the tan column and in the pi on 4 column. So here's pi on 4. And our tan, what we really want to remember is sine over cos, and that comes up heaps. That will enable us to understand why tan is positive or negative. This point here, this is a positive x value or cos value, a positive y value or sine value. So that means tan is positive. So we do want that quadrant. In this quadrant, let's make the next part of the butterfly wing. In this quadrant, you would have a point where the cos is negative and the sine is positive. So we'd have positive divided by negative. That's not positive, so we don't want it there. Let's just rub that one out. In the next quadrant, part of the butterfly again, remembering the butterfly would look like this. And we have, this would give us a negative cos value or x value and a negative sine or y value. Negative divided by negative is positive. So yes, we want that. We're going to have a positive tan value there. And I'm just going to pop that pi on 4 in. And finally here, well, you can probably already tell that's not going to work. Here you have a positive cos value or x value and a negative sine value or y value. Negative divided by positive is negative, so we are not going to be including that because we are after positive values then. So look, let's now measure those angles and answer the question. So we're going from negative pi up to pi, so our values have to lie in between there. So I'm going to go in the positive direction first. So let's put a positive angle. This is going to be just positive pi on 4. So x equals pi on 4, which is within the domain, so I'll highlight that straight away. It's a really easy one there. Let's go around a bit more. So this would be 4 pi on 4 plus pi on 4. 4 pi on 4, let's say x equals 4 pi on 4 plus pi on 4. And you can clearly see that that's going to be outside the domain. So really, you don't have to do that. If you can see that it's going to be outside the domain, you wouldn't waste time doing it. I'm just showing you so you can see why that one's not included. So I'll cross that out so it's clear that I'm not considering that one as one of the solutions. So that's all the angles I have in the positive direction. But it also tells us we can go for a negative angle as well. So let's go in the negative direction, remembering the negative angles go this way. So I'm going to go from 0 in the negative direction by 4 pi on 4, and then in the positive direction by pi on 4. So this says x equals negative direction of 4 pi on 4, and then in the positive direction of pi on 4. So that gives me negative 3 pi on 4. And negative 3 pi on 4 is within the domain of negative pi to positive pi. So I'm going to highlight that as well. And actually I might write it on the new line and make it a bit neater there. So x equals negative 3 pi on 4. Now, I can tell that that's going to be the end of it. They're the two solutions, and they're the only two solutions I have here. But for the sake of just pointing out to you why, I'm going to do one more. And that would mean that I go negative 4 pi on 4, negative 8 pi on 4, and then I go in the positive direction by pi on 4. So this would be x equals negative 8 pi on 4 plus pi on 4. And that would mean x equals negative 7 pi on 4. And well, that is too small. We are going from negative pi to positive pi. Negative 7 pi on 4 does not lie within that domain. So I'm just going to cross that out. So our only two solutions for this domain are here and here. And that completes the first example.